So now up to this you know that what is balance section. Do you know that what is balance section?
Yes, sir.
Okay, tell
স্যার
me.
আন্ডার স্যার
Hello.
বলবো
বলো বলো।
স্যার ওটা হচ্ছে আপনার মানে সেম লোডের মধ্যে কংক্রিট আর স্টিলটা তাদের পারমিসিবল মানে একসাথে তাদের পারমিসিবল স্ট্রেসে রিচ করতে পারে।
Yes, when concrete and steel both simultaneously reaches its permissible value of stress, okay, then we can say that this is balance section. Okay, now you just think, if we provide less amount of steel on this single reinforced section than the balance section. Suppose this section is balance section and this is reinforcement AST1. okay, and for this case we have provided the AST. This is actually AST2 and AST1 is greater than AST2. okay, or AST1 is actually AST for balance section. Okay, now what will happen for that case? The load, you know that the stress, formula of stress is nothing but force by area. Okay, now you can understand the relation between stress and area. If area is less, then stress will be high. That means stress is inversely proportional with area of steel. Okay, so if AST is AST1, if AST2 is less than AST1, then we can say that for the balance section the produced stress in steel is AST1, and for that case this is AST2, and AST2 is nothing but it is greater than AST1. So AST1 is less than, sorry, sigma ST1 is less than sigma ST2. okay, because sigma ST2 is greater than sigma ST1 because ST2 is less than ST1, nothing but. Okay, so we are providing minimum amount of AST for this section. That's why stress produced in stress produced hello. Now stress produced in this section is AST2, which is greater than ST1. Now you just consider, say this is for sigma C for concrete, stress for concrete, and this is sigma S for steel. Okay. hello, hello. Subhash Banerjee. What happened, Subhash Banerjee? Hello? Subhash Banerjee, what happened? Now for balanced section, say sigma C reaches its permissible stress sigma CBC, okay, and sigma S, that is stress in steel, reaches its permissible stress given in IS code table 22, that is sigma ST. Okay, now for this unknown section, for this section, sigma C reaches its sigma CBC for concrete, and sigma ST, this is sigma ST1, okay, and this is sigma ST2, okay. So for concrete, for balance section, sigma C reaches its permissible stress sigma CBC, and for steel, stress reaches its permissible stress sigma ST1. This sigma ST1 is nothing but this sigma ST1, okay. And for this section, stress in concrete reaches sigma CBC, and stress in steel reaches sigma ST2. This is sigma ST2. So sigma ST1 is less than sigma ST2. Now please keep in mind this table, okay. After that, I change the slide and I'll tell you in details. So for balance section, sigma C reaches sigma CBC, and for this section also sigma C reaches sigma CBC, and for steel, sigma S reaches sigma ST1 for balance section, and for this section sigma S reaches sigma ST2, okay. Now if we consider the balanced section, suppose this limitation is
কিছু একটা সাউন্ড আছে স্যার।
সেটাই আমি দেখছি।
সুভাষ নস্করের কাছ থেকে এসেছিল
না, ওটা সুভাষ ব্যানার্জি লেখা ছিল।
হ্যাঁ স্যার, হ্যাঁ ওইটা।
Now this value is sigma CBC, and this limitation is sigma ST or sigma ST1 for balance section, okay. Now when we are gradually applying a load on a particular beam, then this strain line will rotate in clockwise direction, and it will rotate like that, and ultimately concrete reaches its sigma CBC at final stage, and steel reaches its sigma st1 in final stage. Okay, this is for balance section. Now if I consider the second case, suppose this is sigma CBC and this is sigma st1 and this value is sigma st2, because sigma st2 is greater than sigma st1. Okay, sigma st2, this total distance is sigma st2 and this total distance is sigma st1. Okay, now when we apply the load gradually, then sigma stress in concrete reaches its sigma CBC and stress in steel reaches its sigma st2. Please keep in mind, reaches is sigma st2 and this is sigma CBC. Okay, now if is it possible for this case, for the second case, to reach the stress in steel up to sigma st2? Is it possible? No, it is not possible, because IS code provides us this limitation, this permissible stress sigma st1. Beyond this sigma st1, it is absolutely invalid. Okay, so this portion is absolutely invalid. Okay, so how the strain line will rotate for that case? Strain line, now if I connect sigma CBC and sigma st2, then this is the strain line. Now because of this case is not possible, because stress value of steel could not reach in sigma st2, because IS code provides us only this sigma st1 value. Okay, beyond sigma st1 we cannot go in case of steel. Okay, so the strain line will rotate and it will stop at this particular point, Okay, now if I draw a strain line here, then you can see this is the strain line. Okay, so this is actually a straight line. Okay, this is the straight line. Now you can see that the strain line rotate in clockwise direction about the neutral axis. This is neutral axis. Strain line rotate in clockwise direction about the neutral axis and it will rotate up to this point only, up to this point. Okay, so beyond the sigma st1 you cannot go. Okay, now you can understand that the value of concrete is actually sigma c, which is less than sigma CBC. So for this section, when we apply some less amount of concrete, say AST2, then concrete stress in concrete, I should say, stress in concrete will be minimum than the permissible stress, because stress in steel reaches its permissible stress first. At the first, stress in হ্যালো, সৌরভ রয়। সৌরভ রয়,
ইয়েস স্যার।
তুমি একবার মিটিংটা লেফট করে আর একবার এন্টার করতো, এখানে এন্টার করো।
ওকে স্যার।
একবার লেফট করে যাও, এন্টার করো। ওকে, আজকে মনে হচ্ছে, হ্যালো,
হ্যাঁ স্যার।
হ্যাঁ ঠিক আছে, আজকে মনে হচ্ছে কিছু প্রবলেম হবে এর মাঝে মাঝেই। কোনো একজন স্টুডেন্ট ইচ্ছা করে করছে এটা। ওকে, কি যেন বলছিলাম আমি এখানে?
SP1.
হ্যাঁ, ST1. Okay, when we apply the AST1, sorry, AST2 for this particular case, which is less than AST1, that means we are providing the less amount of AST less than the balance section. Okay, and for that case, AST reinforcement, for that case the reinforcement reaches its ultimate stress at first, and at that time concrete stress in concrete reaches at some amount which is less than the permissible stress of the concrete. Okay, suppose we are considering the suppose we are considering the M20 grade concrete, then we can say that the sigma CBC value is for M20 grade concrete is 7 from IS 456 table 21. Okay, so if we provide less amount of AST here, we can say that stress in concrete should be less than 7. Okay, stress in the concrete should be less than 7 at the time of failure, because what does the mean of failure? Failure means when concrete or steel, any one material will reach the maximum the permissible stress, then we can say the structure will fail. Okay, suppose for that case we are providing less amount of steel, so for that case steel will reach its ultimate is its permissible stress at first time, then we can say that this is the failure position, and for this case we know the value of AST1, we know the value of AST1 because it is provided by IS 456. Okay, table 22. But for this case we don't know the value of sigma C. We don't know the value of sigma C because IS code provides only the value of sigma CBC and sigma ST. So we know sigma ST1 and we know sigma CBC, but for this case the stress reaches its permissible value, but stress in concrete does not reaches its permissible value. Okay, so we can say that we can correlate the bending moment with tension multiplied by the lever arm, and we cannot correlate with compression multiplied by lever arm, because we cannot do that. Okay, we can do only this, because for this case we know the value of sigma ST1 1. Okay, this is the value given in IS 456. Okay, and multiplied by AST 2. Okay, so we have to find, suppose AST2 or AST2 is given, we have to find sigma ST1. Okay, no problem, or any other parameter we have to find. Okay, no issue. We know the value of sigma ST1 that is provided by IS456, but for this case we don't know the value of sigma C. We don't know, because IS456 provide only sigma CBC value. Okay, so sigma C value we don't know. That's why we cannot correlate the we cannot equal the relation M is equal to C into Liveram. We cannot do that. So when you see that the amount of steel is less than the balance section, then you have to go for with this relationship, that is bending moment equals to T into Liveram. That means M, this is actually nothing but M or moment equals to sigma ST AST JD. Okay, sigma ST AST JD. So sigma ST is stress, AST is area, so total is force T, and this is JD is Liveram. Okay, so this is Liveram. Okay, now this type of section is called under reinforced section. Okay, so this is balanced section. And this is under reinforced section. It is very difficult to write anything with the help of mouse. Okay, so that's why the handwritten is very bad quality. So this is balance section and this is under reinforced section. So now if I say that what is under reinforced section, you just you can say that when the permissible value of steel, say this is say when the permissible value of steel will reach first, then we can say this is balanced under reinforced section. So for this case, this value is actually sigma C, and suppose sigma CBC is here. Okay, so this is sigma CBC, and this value is sigma ST, and this value is sigma CBC, and this value is sigma C. So when stress in steel reaches first to the permissible stress given in IS 456, then we can say that this is under reinforced section. And if I correlate the under reinforced section and balance section, if I merge two things, the balance section is that when stress in concrete and stress in steel both reaches its permissible value, then we can say this is balance section. So stress in concrete is sigma CBC at here, and stress in steel is sigma CBC, sigma ST is here. So we can draw a stress line like that, and we can say this red diagram is nothing but balanced section, stress diagram of balance section. This red line indicate the stress diagram of balance section, and the yellow line indicate the stress diagram of under reinforced section. Okay, this is under reinforced section. Now one thing you can notice that the neutral axis depth for two different section is totally different. Okay, okay. Now this neutral axis is for what? For under reinforced section, and this neutral axis is for balanced section. Now you can understand the difference between under reinforced section and balanced section. Number one is for under reinforced section, AST is less than AST for under reinforced section is less than AST for balanced section. Okay. Number two, we can say that stress in steel, sigma ST for both case is same. Sigma ST for under reinforced section equals to sigma ST for balance section also. Okay, this is the sigma ST value, and for both case sigma ST value is same. And number three, sigma C for under reinforced section is actually less than sigma C of balance section. So sigma C for balance section is nothing but sigma CBC. Okay, so this value is nothing but sigma CBC, and this is we don't know this value. We can calculate this value. No, this is not rocket science. Simple problem formula is there. I will show you. And the fourth point is there, that is neutral axis depth for under reinforced section. Neutral axis depth for under reinforced section is less than neutral axis depth for balance section. Okay, now what is neutral axis depth? Neutral axis depth, we generally consider this neutral axis depth from the topmost fiber. So this is the neutral axis depth for under reinforced section is less than the neutral axis depth for the balance section. Okay, you please keep in mind all those 4 point. Okay, because when you will go to solve any numerical problem, you have to choose what procedure should follow. Okay, when we go for numerical problem, you can see all those points you have to keep in mind. Now you know the difference between under reinforced section and balance section. Now if I provide the reinforcement which is greater than the balance one, then what will happen? You know, stress is inversely proportional with area. So stress is force by area. Okay, so stress is inversely proportional. Now if I increase the amount of area, then stress will decrease. Okay, now we have apply AST3. AST3 which is greater than AST1. What is AST1? AST1 is area of steel in balance section. Okay. Now what will happen? AST3 is greater than AST1. That means produced stress will be less. For that case, produced stress, suppose sigma ST3 will be less than, sorry, sigma ST1. Okay, now you just see, suppose this value is sigma CBC value and this value is sigma ST1 value, and that is provided by IS 456, sigma ST1 and sigma CBC. Okay, and this value is I'm sorry, not this, just let me draw again. Suppose this value is sigma ST1 and ST3 is less than ST1, so this is ST3, sorry, sigma ST3. Okay, now if I say that sigma ST3 and sigma CBC reaches its simultaneously, then we can draw a straight line here. Okay, now think about that. Is it possible to increase the stress of steel up to sigma ST1? Because sigma ST1 is the permissible value provided by our IS 456. Okay, and sigma CBC is the permissible value of stress in concrete provided by IS 456. Is it possible to increase the stress of steel up to sigma ST1? Is it possible? If it is possible, then we can draw a straight line. We can draw a straight line here, and let me draw it. So suppose this is the straight line, sorry, stress line. This is the stress line. Okay, now you can see, for that case, sigma ST3 reaches its ultimate stress sigma ST1, but for the concrete, sigma CBC the stress of concrete is exceed the sigma CBC value. Okay, so this value is obviously greater than sigma CBC, and obviously code will say that you cannot go beyond the sigma CBC value. Okay, sigma CBC is the permissible value, and you cannot go beyond that limit. So that means this line is the final failure line of final failure stress line for that case. Okay, now what is the failure position? Failure position is this line, because previously I have said you that when concrete and steel, one of them will reach the ultimate stress, then we can say the member has failed. Okay, so sigma stress for concrete is sigma CBC. You have to reach sigma CBC, or either sigma CBC or sigma ST. You have to reach either sigma CBC or sigma ST, and for that case sigma CBC reaches at first. Sigma CBC, not sigma ST. Okay, so we can say that bending moment equals to C multiplied by lever arm. C multiplied by lever arm, and we cannot say bending moment equals to T multiplied by lever arm. We cannot say. Why? Because T actually is sigma ST value multiplied by area of steel. Okay, and we don't know the value of sigma ST. We don't know, because we have the permissible value, but in our case sigma ST value is less than the permissible value. Got my point? So we cannot write this equation. We have to go with this equation, and you know that sigma, this C is nothing but sigma CBC multiplied by area. Okay, now you know the value of sigma CBC, because ISO 456 provide you the value of sigma CBC, and you can go for this formula. Okay, now if I draw a balance section here, that means the stress in steel and stress in concrete reaches at same level simultaneously. Then if I draw the line diagram here, okay, I shall take another slide for this. Now you if I superimpose those two stress diagram here, suppose this is sigma CBC, and this value is sigma ST, and if I draw a balance section here, suppose this is the balance section, and you have already know that for the another case when AST is maximum, for that case sigma CBC reaches its ultimate stress, but sigma ST is the less than 1. Then if I draw the strain diagram for that case, so sigma CBC will be there, and suppose this is the minimum value for the maximum reinforcement, and this is the strain diagram. Okay, now you can find some difference between two stress diagram. Number one is depth of the neutral axis. So depth of the neutral axis for balance section, neutral axis depth for balance section, neutral axis depth for balance section is less than that section, and this section is called nothing but over reinforced section. Okay. This is nothing but over reinforced section. So neutral axis depth for balance section is less than neutral axis depth for over reinforced section. Number 1. Okay. Number 2, stress in concrete sigma c for balance section is equal to stress in concrete for over reinforced section. And number 3, stress in steel for balance section is greater than stress in steel for over reinforced section. Okay. So when I say the balance section, you can go for both formula. M is equal to C multiplied by lever arm, and M is equal to T multiplied by lever arm. Okay. For both case, for balance section, both equation will be, you can consider both equation. Now when I say this is over under reinforced section, you have to choose only this equation, M is equal to T multiplied by lever arm. And when I say the section is over reinforced section, then you have to go with this formula. Okay, please keep in mind. So there is some another parameter, or I should say there is some equation. That means suppose there is a, this is a balance section, and this is sigma CBC, and this is sigma ST, and this distance is nothing but neutral axis depth KD. So and the total distance is depth of the effective depth D. So two triangle are similar triangle. For this case, two triangle are similar triangle. Now you can calculate the neutral axis depth from this geometry. Okay, from this diagram. So you can say sigma CBC by KD. So sigma CBC by KD equals, we can say, sigma ST by this distance. So sigma ST, and keep in mind this is not actually sigma ST. In our working stress method, we have converted the sigma ST in terms of concrete, and this is actually sigma ST by M. Okay, so this is sigma ST by M by this distance, and this distance is nothing but D minus KD. So this is D minus KD. Okay, now you can calculate the K value. You can calculate the K value here. And this sigma CBC you have to find out from table 21. This sigma ST you have to find out from table 22. Okay, this is table 22 and this is table 21, and this m is nothing but 280 by 3 sigma CBC. Okay, now you can find k value here. That is the formula. I shall show you in the next class how we can calculate the all parameter, that is k value and Leverhulme distance. Okay, how we can calculate the stress in steel from this equation C is equal to T. Okay, in the next class I shall show you. Okay, now I stopped here, and you please tell me if you have any doubt in this class. You can tell me if you have any doubt. So just a minute, I shall take the attendance. Three.